Hi gang, this is 8.1. So before I start this section, I just want to go over an old item. This was on test 1. The domain's going to come up again, and that's a good thing because that'll be on the final. So it's, in this case, it's in function notation. Don't let that freak you out. When you're doing the domain, again, it doesn't have anything to do with the numerator. You just want to figure out where the denominator is equal to 0, right? Because it can't be that. It's not allowed to be that. So z here can't be -3. If it's -3, you're going to be dividing by 0, right? If you put in -3 in this problem, you're going to get 5 over 0, which is undefined, right? So that's why it's a domain restriction. So the domain of this, I'm just going to shorthand it here because you guys know you can write it all the different ways, but so z there can't be -3. All right, now this is really important, and I think this tends to confuse people. The biggest mistake people make with simplifying is that they reduce over a plus or minus, and you can never do that. That never works. So let me just show you here with just real numbers because it'll help you. So like if I, order of operations, this is sort of like nested up here. I'd have to do this first. So this is 10 over 2. So this is 5. The accurate answer to this is 5. Now what people tend to do when they see variables is they think that they can cross out the same thing with the same thing, which is absolutely wrong. That never works. So if there's a plus or a minus and you do that, so now I think the answer is 8, which it isn't. So please don't ever cross out over a plus or minus, because it's always going to equal to something that's wrong. It just will never come out right. So don't ever do that, okay? So I'm just trying to show you with this that if there's a plus or minus, don't cross out over the numerator and the denominator. You can only cross out over multiplication. All right, let's talk more about that now, but it's in terms of variables, and that's why I wanted to do numbers. All right, so what I was just saying is that you can't, like, for instance, cross out a D with a D. That doesn't work because it's connected by a minus. So the first step is actually to take out, in this case, take out the common factor of 5. And in the denominator, the common factor of 6. And now, since these are connected by multiplication, I can take the whole thing out. Notice I'm not taking it out over the subtraction. I'm taking it out over multiplication. So the final answer for this one is 5 over 6. So when you do these, there's all the varieties are going to be mixed together. So the top part of this to factor this is going to be factor by grouping. I'm just going to do it above it to save a little space. If we take out a u from both of these terms, we're left with v plus 3. Take out a minus and a 4, v plus 3. All right, and then if you take out the common factor, which is this guy and this guy, it's v plus 3 times u minus 4. Okay, that's the numerator factored. V plus 3 u minus 4. Now the denominator is a difference of perfect squares. So that's v plus 3 v minus 3. So once it's factored and what it's connected by is multiplication, that's when you can cross out the same thing with the same thing. Okay, so you can never do it like before over addition or subtraction, but once you knock off the whole block of it over multiplication, you're good. That won't give you an error. Now this topic's a little weird here, so I just want to take a moment to go over it. If one is like opposite sign of the other, so what you want to do there in that case, like I'm going to leave the numerator as it is because it is already in descending order, but this guy is backwards in the denominator. So the idea is this. You're going to take them and switch the order. So I'm going to put the negative q in the front and the 11 in the back. So what I'm doing is I'm switching the order. You're just like changing seats. Instead of this guy being first in line and this guy second, this guy's first in line now and this guy's second. All right, then you want to factor out a negative. All right, so now I'm going to factor out a -1. I'm going to be left with Q minus 11. So I'm going to put this over here. Oh. Okay, so what's going to happen here, and you can really bring the negative up to the middle, but what's going to happen here is this is going to reduce with this, and depending how your brain sees it, some students will see it like that. That's just going to reduce. However your brain sees it, it's going to reduce then to a -1. This guy could have just been brought up to the middle, and so then when this reduced, it's a -1. Remember, the same thing over the same thing is a 1. It's not 0. Anything over itself is a 1. It's not a 0. So the same thing over the same thing is a 1. It's just that we have an extra negative floating around, which is why it's that. All right, same thing here. Let's just try that again because I know this concept's a little weird. So in this case, this one's in descending order. This one isn't. So I'm going to switch the seats. Right? Musical chairs. Switch the seats. Now I'm going to factor out a -2. I'm going to get that. Alright, so what I want the numerator to do is look like what I just did. Now the denominator is a difference of perfect squares. Alright, so now since these are all over multiplication, now that's why I can cross it out. And again, I couldn't cross out this with this because it's connected by subtraction. Right? The only time you can cross out, you have to think of them as like big Legos. You can cross out a big Lego with a big Lego when it's connected by multiplication. Alright, I'm going to do more of this section, but let me just end this video here because it's already at 7 minutes. Alright, catch you in another video on 8-1. Okay, bye-bye.